My name is Lexis Castor, and this is how a normal protein can be transformed into a mutant protein as a result of the addition or deletion of a single base pair. What is shown here is our normal protein sequence along with our normal coding sequence, and our mutant protein along with our mutant coding sequence. So since codons can sometimes code for the same protein, we list all of our options of codons until we compare with our mutant coding strand to find out exactly which codon we're using. So what we're going to do first is go through and compare each coding sequence and find the point at which they differ. So AUG, I'll get there, UGG, and then a U and an A. So if it was a deletion, in the normal coding sequence, there would be an A either before or after this U. So if we look before, it's a G, and if we look after, it's a U. So that means that it is not a deletion. It's going to be an addition of an A right in front of that U. So if we go back through and compare, we have AUG, UGG, now we have A, UU, because there's no option for this U, so UU. So that means C and A are not an option, it's going to be that U, because that's what matches up with our normal. Alrighty, and then our next one for here is going to be a C. So since we have an option here, that means this one's going to be UUC instead of UUU, which doesn't change the protein that it's coding for. Okay. AC, AC, so that means this is going to be CAC. And then we have a lot of options for this one. Since it's on our mutant, only a U, so this means that's going to be a U. AA, AA. So that is our stop codon. So that is how a normal protein can be truncated into a much shorter mutant protein. And this point mutation is going to be a nonsense mutation. Since a previous protein was coding for a normal protein, it's going to be changed into a stop codon.